My name is Tom, and in this video I am going to walk you through the solution to a common type of SAT math problem. And this is in the context of what is called a defined operation. Okay, so you have to think back to, for example, when you're a small kid and somebody first told you, here's a symbol, and of course now we know it represents addition, the combining of things together, but when you're a child, somebody has to tell you that this has a certain meaning. On the SAT, you may see symbols that look like this for various operations. They may use a triangle, or maybe they will use a square with two lines across it. So each of these represents some operation in terms of more familiar operations. Let's take a look at an example. Say you have something that looks like this. X circle dot y. So you may see this, and this is the defined operation, and the definition of this operation might be x squared plus y over x. So this is the symbol, a little circle with a dot inside it, but on the right side it's defined using more familiar operations, meaning squaring, addition, and division. And of course, what they will ask you to do then is the following. They will give you a number for x, like 2, circle period, and then for y they may give you a value such as 4, and they may ask you to evaluate this, which means the following. Wherever you see x, you replace it with 2, and you square. Wherever you see y, you replace it with 4, and you write it over the 2. So let's simplify. We have 2 squared, which is 4, plus 4 divided by 2, which is 2, which gives us the result altogether of 6. So 2 circle dot 4 is 2 squared plus 4 over 2. This is 4 plus 2, which is 6. So the defined operation here is this operation, and it's defined in terms of squaring, addition, and division. You may also be asked to solve an equation using a defined operation. In other words, it may have the following appearance. You may be told that, for example, x is 3 and y is kept as y, as a variable. So then what you have is 3 circle dot y equals, and wherever you see x, you replace it with the number 3 and you square. So 3 squared plus y over 3, and you may be told that this is equal to some number such as 16. So the key observation to be made here is that this is just a linear equation. So let's rewrite it as follows. 3 squared is 9 plus y over 3 equals 16. How do we solve a linear equation of this kind? We take the 9, move it to the right side. So we will have y over 3 equals 16 minus 9. And then to get rid of the 3 under the y, what we can do is just multiply across by 3 on both sides. There we are. Of course, this 3 and this one cancel, and all that remains is y equals 16 minus 9 times positive 3. Okay? So this is 7 times 3, which is 21. So what this tells us is the following, that if I replace x with positive 3 and I replace y with positive 21, then this defined operation will yield a value of 16. Let's check. That's a crucial step. Being able to check your work is important, so you don't have to feel unsure of yourself. we have the following: x, 3, circle dot, replace with 21. Let's see what this yields. We will have 3 squared plus y, which is 21, over x, which is again 3. So let's simplify. 3 squared is 9, plus 21 divided by 3, which is 7, and 9 plus 7 is 16. So this confirms that y being 21 is correct. So one more time. This is what's known as a defined operation. It is called a defined operation because it's some operation using a new symbol that is defined in terms of more familiar operations, such as addition and subtraction and what have you. To evaluate simply means to replace the variables with the values given as always. Whenever you evaluate an expression, that procedure is the same. You may also be asked to find the value of either x or y or some other letter in the equation. If you are told that the value of this is equal to some number, then you carry out these steps. And then to check that this is the correct value, go back to the original, replace x and y, and confirm that what you get here is equal to what the problem said originally, such as the 16. Thank you for watching.